Right. So I think last time we solved this with a Pascal triangle. So I'm gonna try to solve this again, this Pascal triangle. So if you want, you can work with me as well. Yep. So let's see. We're gonna have 1, 1, 1, 1. We have 1, 1, 1. So then we have 2, 3, 4, 5. So we have 3, 4. Added together, we have 6. We have 10. We have 10. We have 20. We have 15. Then we have 35. The answer is 35. Right? Yeah. So you can see this work perfectly. However, it's just so tedious, a lot of tedious work, right? So now we can look at if we have a better solution. So any student know how to solve this without Pascal triangle? All right, so I give you the hint, right? Then I want you to find the formula. So you can see here, this total is 7 steps. So we can go to right. So you need to go to right 4 steps. No matter which path, you need to go up 3 steps. So if I mark go to right step, each step as R. So you need a 4 step go to right and go up. I'm gonna use U. So you're gonna use 3 step go up. How many ways? This is for this 7 step path. Wonderful. They just arrange the letters. 7 factorial divided by 4 factorial, 3 factorial. I saw something give me. Or the other way is out of a 7 step, you choose 4 step as R. The same as out of a 7 step, you choose 3 as U. So this is the answer, no matter which one you like. So basically 7 choose 4 or 7 choose 3. Right? So you can find out this one actually is 7 times 6 times 5 divided by 3 times 2 times 1. So cancel. We got 7 times 5, 35. Wow, that's easy. All right, so you got this point? Right. So let's look at this again, right? So basically now we have this in our homework. So this one I believe you spent quite a lot of time to find out. The answer is 252. So I want you to think it over. So how to solve this one without Pascal triangle? Right. So you can see this is gonna be 5 step, 5 step. So just like a D, we call down. You need a 5D and a 5 right, 5R. So basically just arrangement of these 10 letters. We can write is a 10 factorial divided by 5 factorial, 5 factorial, or 10 choose 5. Right, which is also 252, right? I think Bowen already calculated. Yes, this is a 252. All right, so now we're gonna look at furthermore. Let's see, we're gonna go to look at this one. Yep. So this is basically the Pascal triangle. So we know the pattern. We have 1, we have 1, 1, 1, 2, 1. So 1, 3, 3, 1. So this is a pattern, right? So actually we're gonna using this one to think about the how these correlate these past problem, right? So actually we can just think about starting from this corner, this origin, right? We can think about the origin. So let's think about a case. We call this side is x, this side is y, like coordinate plane, right? Let's think about 3 steps. Where are the points we can reach within 3 steps? We can reach here, we can reach here, we can reach here, we can reach here, right? So you can see this space is x, x, x. You need to go x direction 3 times, right? So for this one, there's you need to go right 2 steps and go up 1 step. But there are various ways to do that. We can do x, x, y, x, y, x, x, y, x, x. Basically, that's just reorder these 3. We have 3, choose 1, 1 for y, right? This basically is 3, choose 0. So if you look at this base is x, y, y. So just 3 choose 2 ways, right? So this one we have y, y, y. Just 3 choose 3, right? So this is combination, right? Let's correlate to our answer, right? Okay, so let's see if we look at, so this base is the case. So we have xx, xy, xxy plus xyy plus yxx. So you can see here we have, if you think about this, is 3x squared y, right? So this actually, if this is 3xy squared. So this is a y cube. So this is x cube, right? So you can see 1, 3, 3, 1. That's Pascal triangle number, right? Okay. So if you continue, what about 4 step? 4 step, this is going to be x to the power 4th. This is going to be x3y. So this is going to be x squared y squared. So this is going to be x y cubed. This is going to be x also y 4th. So tell me what I should put here. This is going to be 4 choose 0. I don't want any y's. So what I should put here, 4 later I want to find 1 position to put y. So 4 position 2 will be y. So 4, 3 be y. So 4, all 4 be y. Right? So then that will be the number count. Right? Okay. All right. So I think these just correlate. So we have 0, 0 for the first row. We have 1, 1, 1 choose 0, 1 choose 1, 1 to 1. That's correlate to this row. And then this correlated to this row, and this row, right? So this is the number, right? Okay. Now I think another very advanced knowledge called binomial expansion. So probably you're gonna learn this at the at algebra 2 probably. That's usually it's a 10th grade course. So if you have x plus y, this is called binomial. To power 0, to power 1, to power 2, to power 3, right? So those are called binomials. Expansion to the third power, right? So I think we just look at this one. x plus y to power 3, you got the coefficient is 1, 3, 3, 1. That's Pascal triangle number, 1, 3, 3, 1. Right? So you have x plus y squared, you have 1, 2, 1. So that's Pascal triangle numbers. So you probably see the correlation here, right? So let's take another look. So I think basically this is going to be the idea. So we have x plus y to power 3. That's equal to x plus y times x plus y times x plus y. So at each step, you can either pick a x or a y. Each pick a x or y. That's just like you go through the graph. So reach, if you pick all three, be x, you're going to reach here. 1x, 2x, 1y, you're going to reach here. So that's why you make this xx. So you can only pick x and construct this, right? If you want to construct this, you're going to pick this and pick this y. Or you can pick this x, this y, and this x. This is just how to arrange this. That's why you have the Pascal triangle number here, right? So this one, basically, we can just look at more clearly. So for x, out of a 3, you need to choose 0, be y. For this one, out of a 3, you're going to choose only 1, be y. Out of a 3, this one, you're going to choose 2, be y, right? So this one, you choose all 3, be y, right? Now give you the challenge, right? So next one. So, oh, yeah, you know how to do it. This one, right? Let's see. This basically 4 choose 0, 4 choose 1, 4 choose 2, and 4 choose 3, and 4 choose 4, right? So we can find this basically equal to, this expansion equal to 1x power 4. So this gives you 1. Plus, this gives you the coefficients of 4. 4x power 3 y plus this one. 4 choose 2 will be 6 x power 2 y to power 2 plus this one. 4 choose 3 actually, which is 4 x y to power 3, then plus this is 1 y to power 4. Yes, we expanded, right? So this is just how you do this. You can see how these correlate. This is just 4 choose 1, right? This is just 4 choose 2. So this is just 4 choose 3. This is just 4 choose 4, right? Okay, so this is just the idea of doing this. Okay, so now we're gonna look at a challenge question. What about x plus 4, x plus y to power 7? We have, yep, so x power 7, x 6 y, x 5 y 2, x 4 y 3, x 3 y 4, x 2 y 5, x y 6, and y 6, right? Oh, y7, sorry, last one is y7. So this one basically is 7 choose 0. We don't have y. Plus 7 choose 1, 1y. Plus 7 choose 2y. Plus 7 choose 3y. Plus 7 choose 4 as y. Plus 7 choose 5 as y. Plus 7 choose 6. Plus 7 choose 7. Right? So now you just using formula. This is going to be x 1x power 7 plus 7x power 6y plus this one going to be, let's see, 7 times 6 divided by 2, 21 x power 5 y squared plus this one, I think 35 x to the power 4, y to the power 3, plus this one actually have same number, 35 x to the power 3, y to the power 4, plus these actually have the same as here. You have 21 x squared, y to the power 5, plus 7x, y to the power 6, plus 1 x to the power 7. Wow, that's a really hard question we solved. All right, so I think this one is the idea, right? So this one, so let you think about if we have 2 power n. So can you come up a general formula?